example 21 asks to find all of the angles between 0 and 2 pi which satisfy the equation, and they give us a couple of different ones. Now, there's a couple of new concepts here that we're going to work with, but the main thing that you want to keep in mind is always look when you're doing trig equations, what window are they asking? So this one's between 0 and 2 pi. Now, I'm going to make a suggestion, the suggestion being that depending on what kind of answer you get, degree mode in your calculator may be helpful, or radian mode may be helpful. So it depends on whether or not it's going to be on the unit circle or not. That's kind of critical. So anyway, the first question gives us 5 cosine of x equal or minus 4 equals 0. So what we're going to do here is solve for the cosine of x and then use that to figure out what the angles are. So we're going to add 4 over. So we're going to get 4 cosine of x equals 4. And then we're going to divide by 5. So we're going to get the cosine of x equaling 4/5. Well, when we have this, now this is not on the unit circle, and we're asked to solve in terms of radians, okay? So this makes things a little complex. Now, if we were to do the arc cosine of these, and again, make sure that we get into radian mode. So for an arc cosine, so we're going to do this of 4/5, and that gives us 0.6435. So that's in terms of pi. Realize this. So when that's not in terms of pi, or yes, it is in terms of pi. The pi's have already been multiplied in. Sorry. So our answers officially, one of them at least, is 0.64. 0.64 radians. So let's think about our unit circle here for a second. Now, cosine is going to be, let's see, this was 4/5, so that is right here roughly. Okay, so we're expecting the same thing on the bottom. So in order to figure out how that's what that answer is, now we know that this is 0.64 up and this is negative 0.64, but we're not allowed to answer negative 0.64 because we're supposed to answer between 0 and 2 pi. So what we have to do is realize, how do we write this negative 0.64 with 2 pi? So we can either think of it as you're doing 2 pi minus 0.264, or you can do 0.64 plus 2 pi. Same idea. So imagine that we're taking this negative and we're going around the circle 2 pi. So we're going to add 2 pi to it. So this, again, we're going to get decimal answers, not in terms of pi. So this is 6 point, all right, nope, not that, sorry. 2 pi plus negative 0.64 gives us 5.64. So these answers don't have pi in them because this already been multiplied in. Now, when we're doing values on the unit circle, the pi will be involved. It's nice and it's easy. Those are nice, easy landmarks to find. But if we don't have that, then we've got to make sure that we're answering in the right window, and so we're using the same logic from the unit circle. But decimal answers can happen, but normally you'll see the answers with pi involved. So anyway, let's look now. The next topic, the next concept, and the next problem, it adds a little wrinkle to the plan, and so we got to think back to our graphing and how the graphing looked in order to help us out there. The question is 2 cosine of 2x, so that's something new. We get 2 times the cosine of 2x plus the square root of 3 equals 0. Now, this changes things in a few ways. The major way is that now we have double an angle. Now, if you go back to your answers, if we go back to our graphing thought, doubling this number inside actually doubled the period of our graph. So like, instead of cosine looking like this, it is now going to do this in double time. So it's going to be right? It's going to create 2 loops in the same amount of time. So that's going to create more answers for you. And so what we have to do is we are going to expand our window, because now, and you'll see how this is going to take care of itself. Instead of looking between 0 and 2 pi like normally we would, because it says 2x, we're going to start off thinking all of the answers between 0 and 4 pi. Okay, so because we have double, we're going to pretend like we had double the space, because when we divide back by 2, everything will work out. So because that's double, we have to kind of fake out our window a little bit by expanding it, only at first. But trust me, when we divide it back in, it'll all kind of make sense again. So we treat it just like the other problem. So we're going to first move this part over. So we're going to get 2 cosine of 2x equals negative square root of 3. And we're going to divide by 2, and we're going to get the cosine of 2x equals negative square root of 3 over 2. Well, this is really helpful because this is actually a value on the unit circle that we can find. So if we think about our circle here, think about it. So negative square root of 3 over 2 is kind of down here. So we've got, what values does this make? Well, remember we have 2x, so that's important. So we're going to have 2x equals, so we got to figure out what's our first angle. The first angle that we're at is going to be 4 pi over, oh wait, oh, I'm doing cosine, aren't I? That is a mistake. Sorry. So it's these two. So that's my apology. I apologize. So these 2 angles that this makes, that is going to be at, let's see, what is this? 5 pi over 6. And this is going to be 7 pi over 6. Okay, so awesome. Except that's just between 0 and 2 pi. Now I have to think about doubling that and keep going. So the easy way to do that is add 2 pi to each of these answers. Now how do I quickly add 2 pi to these? Well, if we're talking about a base of 6, 2 would be 12 sixes. So I can add 12 pi to the top of each and get what I want. So my expanded extra answers by adding 2 pi, so this is going to be 17 pi over 6. And then I'm also going to get 19 pi over 6. And so that's adding 2 pi to that. So that gives me more and more options. Now, here's what we see right off the bat, which is blah, 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 blah. We have 2x equaling all of this, right? And so this all works. But now we have to divide by 2 to solve for what the x would be. Now this is going to put us back in our regular window when we divide everything by 2. So one thing that makes things very easy is dividing by 2 can either be accomplished by multiplying our denominators by 2 or dividing our numerators by 2. So which one would we choose in this situation? Well, because all of our numerators are odd, dividing by 2 would give us a fraction. So that would not be a great thing to do. But we can double the denominator, and that automatically solves for what we want. Now just realize there's multiple ways to do it. So we're going to get 5 pi over 12. This is going to be 7 pi over 12. We're going to get 17 pi over 12. And we're going to get 19 pi over 12. Now notice how all of these are nicely in between 0 and 2 pi. And they seem kind of strange, but that's because, we're doubling the period, so things kind of get a little weird for us. But this would be our final answer. So just in case, if they change the input, you need to make sure that you account for that by expanding your window at first. Then you can go back and adjust for it later.